Hello, my name is Jerome Ramos, and I'm a recent graduate of Brown University. Today, I will be talking about my paper, Search Result Explanations, Improve Efficiency and Trust, which was co-authored by Professor Karsten Eickhoff. Search engines have become an essential information source. Due to their ubiquitousness, it becomes increasingly vital that they provide unbiased results. Unfair search engines can potentially lead to significant negative social and economic impact. Machine learned models that use large scale as a basis for learning may end up mirroring or reinforcing existing bias in the data. For example, social media accounts with non-Western usernames are more likely to be marked as fraudulent since spam classifiers are predominantly trained on Western names. Additionally, studies have shown that users prefer documents at earlier result list ranks even though factual relevance may be lower. Model complexity aggravates the situation, as rankers increasingly rely on supervised learning from millions of user interactions via highly parametric nonlinear models. Even technology-affine users struggle to discern the exact criteria that led to the final ranking. This lack of transparency may lead to decreased search efficiency as users struggle to find relevant material. This is especially true in exploratory search or situations where the searcher holds low domain expertise. Research into search result visualization prominently includes efforts to explore the use of colors and shapes to provide additional term distribution information to searchers. This family of approaches, tile bars, shows users the document length and the density of query terms relative to the document. You can see an image of tile bars to the left. Hot maps and hot map word bars display the term frequency of query terms over all returned documents. You can see a picture of that to the right. These early approaches use Boolean retrieval models rather than core ranked lists. In addition, these interfaces are significantly different from those found in modern search engines, which could potentially have a higher cognitive load for searchers who are more used to current commercial search solutions. Research has broadly explored using alternatives to graphs for visualizing information. However, studies have shown that users prefer bars over numbers for this purpose. Here's a UI for our paper, dubbed Titles Abstract Bars. We decided to use a modern approach to search visualization to lower the cognitive load for users. In the middle at the top, we can see a search bar to enter queries. Below, we can see search results for that particular query. Each document is giving a bookmark button, which users can use to save a particular document that they find important. To the right of each document, we have a score ranking, which is calculated by Okape BM25. At the top left, we have a hamburger menu that opens up a bookmark list of documents that users favorited, and you will see that on the following slide. And at the end, there's a button for users to click after they finish the study, which is used as part of our experiment. So if you click the top left button, it'll open up this page, which shows users to bookmark articles, as well as a survey question, which is particularly helpful for users during our experiment. If you hover over the bars for each ranking, we can see how each word contributed to that document score. So we have three distinct experimental conditions: title abstract bars, which you've seen before, and titles abstract and titles only, which we'll cover in the next two slides. Cranfield collection, which is a document of collections on aerospace, is used as part of the experiment, and users are asked to find out what are the structural and aeroelastic problems associated with the flight of high-speed aircrafts. After performing exploratory search to try to find the answer to this question, users complete a 4-question quiz to confirm the task completion. And this is primarily used to filter out workers who didn't make a non-serious attempt at the task. Users answer a survey after completing this 4-question quiz to document their experience with the search engine. And 50 workers were used per condition, and these workers came from Amazon Mechanical Turk. So here's the UI for Titles plus Abstract, which is identical to Titles Abstract bars, except the scores are not shown. Titles only is identical as well, except the abstract and the scoring bars are not shown. So gathering all the data, each user was asked questions about the simplicity, transparency, trustworthiness, and accuracy of their given search engine. We can see that titles abstract bars outperform the other two conditions quite easily, and the red bars represent strongly disagree, all the way to the dark green bars, which means strongly agree. So we can see the average score for titles abstract bars was much higher than the other two. So Title's abstract bar users were able to complete the task much faster than the other two conditions. Additionally, we asked users questions based on the NASA TLX instrument to measure cognitive load, and Title's abstract bar users reported significantly less frustration and mildly lower levels of mental and temporal demand. For all questions, Title's abstract bars scored considerably higher, but interestingly, Titles only found mildly higher acceptance than Titles abstract. This paper describes early results in an ongoing effort to measure the effect of retrieval model explainability on system quality. In a crowdsourced study, we showed that search interfaces, including even simplistic ranking explanations, are perceived as significantly more intuitive to use while simultaneously instilling greater trust in their results. While explanations did not increase the overall likelihood of search success, they led to significant efficiency gains, letting searchers find relevant material faster. These findings are encouraging for future inquiry into this direction. In particular, we aim to study the effects of explainability more broadly as domain and task complexity, result list quality, and system complexity are varied. If you have any questions, feel free to reach out to me or Professor Eichhoff. Our emails were listed at the beginning of the video. To see the full paper, check out more of our lab's research, check out the links posted. Thank you for your time, and I hope you have a great day.